Hey, it's me, Destin. Welcome back to Smarter Every Day. A treadmill is a pretty simple device, right? You set the speed you want, you get on, you start moving, but you don't actually go anywhere. This technology, people have realized for a really long time, is perfect for virtual reality because you could walk somewhere and actually use your body, but not leave the confines of your own home. Okay, here we are in California. We are at a company called Infinideck. This is a small engineering outfit. These guys make a 360-degree treadmill, the one that's in the movie Ready Player One. So the interesting thing is they're a really small company, but they've got a really cool idea. So let's go check out how this thing works. All right, so this is George, and he owns Infinideck, right?
Yep.
All right, and basically Infinideck is a 360-degree treadmill technique that is it safe to say that we've got treadmills on top of treadmills here?
It's a treadmill made of treadmills.
Okay, treadmill made of treadmills. So you can think of it as you've got one axis of rotation here, and each individual treadmill can move in this direction as well, right?
Yeah.
So how do you...
So it's a combination, right? Obviously, if you want to go X, this is our X direction, this is our Y. X is nothing but a treadmill, you know, like any other treadmill. The Y is nothing but the smaller treadmills. Right now, we're using the Vive tracker on you.
Right, so where are the... Yep, there they are right there.
So your tracker's on your rear. We kind of artificially take you about 7 or 8 inches in front of that to get the middle of your CG. And this tries to keep that middle of the CG in the middle of the treadmill right there.
Oh, I got you. So the feed that was one of my main questions is what is the feedback loop, and it's a positional feedback loop.
Yeah, it's fairly simple right now. We're making it better. That's the part we're going to just keep improving for ever, years and years and years.
So the goal. So you have an object, and then I get it. This is called.
It's very visual.
This is a semi-autonomous command position sensor. That's the specific way to say that.
Yeah.
Right?
Now, what we're also doing on this one is you put foot trackers on. When you combine the foot trackers, the headset, and your hand controllers, you now have 6 different points that is tracked on you. And that's enough for us to give you an avatar.
George Jr. told me if I screwed this little VR tracker into the bottom of the camera, we could insert that camera into the virtual world, which of course we had to do. So we're ready?
Yeah.
So I just get in?
Yeah, go ahead. So
all right.
Let me help you get loaded in. All right. So first, let's do your feet.
All right. 2.
This is the CG. You're gonna put that on. Make the tracker be like directly behind your back.
Okay.
So go ahead and put on your headset.
This feels like I'm actually getting in the Oasis here.
And you can tighten.
Oh wow! I can see the camera in the virtual world.
If you look towards me, you should see the 2 controllers.
What the heck, man?
So what we're gonna have you do now, George, gonna pull it.
Okay. Okay, I'm trying to. This is just normal VR, so I can actually see the ring. Now that's something I didn't expect. So I can. It's there.
Yeah. All right. So now let's.
I see my body too. What's up with my body?
So we're gonna sync that with you. So if I can have you stand with your legs straight down and your arms straight out to your sides in a T-pose.
3, 2, 1. Did it work?
Let's see.
Go ahead and move around.
Oh, I can see my body. Whoa. All right. Okay, that's rad. That's really rad. Okay, gotcha. So right now you're tracking the position of my hands and my feet. Dude, that is messed up. All right. So I can see the camera, the Tic Tac there, but what's more important is I can also see this ring. And Griffin, why did you say you have this ring in here?
So this is there to kind of lock you down in the real world without being too much of a burden, to say.
So this is like, you know, when you do an integral, you get the plus C at the end. So this is a boundary condition for me to kind of lock my brain into both worlds. So this is like, this tells me where I'm at virtually and like my body, right?
Absolutely.
Okay. So are you ready to start walking?
I'm ready to start walking.
Okay.
We're going to recommend you have your hands on the ring when you first try this, just so you get used to the virtual world and what that's like.
Okay. So when you start, yeah, I thought it would make sense for it to put me in the center.
Yeah.
Okay, so now, what it's trying to do is this trying to keep the CG of my back in the center of the ring, right?
Exactly.
So I'm going to touch this, and as I walk, okay, it takes okay, I'm there. Okay, I don't want to hit that tree, so I'm going to turn this way. Okay. So I can't really tell if I'm walking 90 degrees or not. Okay, so there's inertia in the rollers. Okay, I thought there might be. So if I move backwards, it's got to keep me there. If I move forwards, so it takes just a second to get used to. Just a couple seconds on the Infinitec and I instantly understood the problems that these guys have to overcome. It's pretty interesting. It seems pretty simple. Whatever direction a person walks, the Infinitec moves in the opposite direction, whether it be X or Y, at the exact same velocity and acceleration. Think about a normal treadmill. Your brain is doing all the processing. Your brain is constantly solving the equation treadmill velocity plus body velocity equals 0. If at any point you don't solve that equation correctly, you start moving relative to the treadmill. This is a very similar problem, but it's much harder. It's harder because there's 2 dimensions, that's the obvious one, but it's also harder because the processing isn't happening in your brain. That processing is offloaded to the Infinitec, which, oh by the way, can't read your mind. There's a delay time for the Infinitec to figure out where your position is and try to change that.
Yeah.
Yes.
And if it tries to do it too quickly, you know, you can have an overdamped and underdamped system. Is that correct?
Yeah.
Is that the right terminology?
Yeah. So at the moment, what we're currently doing, we're trying to make it so that the acceleration on the user in any way that they're not really trying to experience is never more than 0.1 Gs.
Got it.
We found that seems to be about a good amount to not really be, disturbing for the user.
Okay.
So we're trying to figure out where exactly that is and how to do that.
If I walk forward, I'm going to feel an acceleration in one direction on my body because I'm pushing against the floor, right? But then the floor is going to move and it's going to move my body in the opposite direction. So I'm going to feel an acceleration that's negative, which is strange for, a normal walking around human. Then once I hit a steady state velocity, I'm going to level out that acceleration and my body's going to be cool with it, right? But the moment I stop, that's a change in velocity, and the Infinitec has to accommodate for that. It has to move you back to the center gracefully, and one thing that happens is if it tries to move you back too fast, it'll overshoot and then it has to correct. So this is a really interesting engineering problem because it doesn't have perfect knowledge of intent. Like that's the difference. With your brain, you have intent. And so when you're walking on a normal treadmill, you get to choose everything, right?
But you have to understand, over the last few years, we had to, build and modify the Infinitec 2 along with the control system, and there's only a few of us.
Yeah.
So
Well,
it's been challenging all around.
This is why the problem is interesting, because when you're walking in the world, right now my acceleration is 0.
Right.
And then when I stop, I'm used to imparting acceleration to my body, but that doesn't happen till later.
Yes, it's a work in progress. How far you go back, it's
Clever.
it's a challenge.
That's a hard math problem. One thing I thought was really cool is you can use this to be a different size in the virtual world just by changing a constant, right? You can scale how many steps it takes to get around in the virtual world just by a scale factor. Literally a scalar. That's awesome. Oh, there's the same boat. Look at that. It's like I want to jump.
Yeah, you can't get over it.
I'm too I'm too small to get it. Too small to go to my boat, man. That's fun. That's really fun that the model. There's my bench. Look behind you. There's my bench before. In engineering, we have these assignments called technology readiness levels. There's 9 of them, and I would say this is somewhere between a 6 and a 7, which means there's a working prototype that works, and they're just refining the subsystems. They're about to go to production. So it's really cool to be able to walk on this Infinitec before it goes out into mainstream production and see the behind-the-scenes engineering things they're having to solve. It's really interesting. So it's clear George knows all this. I mean, he instantly understands all the variables. I asked him about how tall the person was. Like, if you think about it, your center of mass is at a different length, and so that moment arm is different, and you have to deal with inertia differently, like from the bottom of it's really interesting. Anyway, this is me talking to George, and you can tell he totally gets it. I can imagine that the inertia, overcoming that inertia is different for each person, because if I'm 175 pounds and I move here, it takes a certain amount of torque I'll cut the deck off now. It takes a certain amount of torque for these motors to move me. And that's going to change based on the size of the person. Is that correct?
That's correct, but it's more about your acceleration than the inertia. The deck is capable of moving a lot faster than you could move.
And
So it could pull your feet out from under you if we ever, had it set to do so. So all the algorithms and stuff will have more to do with other variables.
So,
Like your CG imbalance.
and there's a moment arm between the distance from my feet to where my CG is, right? So the acceleration that you put there's going to be this lag time in my brain where I try to counteract that. Is that correct?
Very much.
All right, this is the part of the video where I tell you about the sponsor, and a lot of people fast forward through this part, but this is the important part, because we wouldn't be doing this if I hadn't have listened to Ready Player One on Audible. I'm not going to tell you about Ready Player One, that's old news at this point. I'm going to tell you about the new book that I'm listening to. The sponsor is Audible. You can get a free book by going to audible.com/smarter or texting the word smarter to 500-500. The new book that I'm listening to is called 12 Rules for Life by Jordan Peterson, an antidote for chaos. Now, I'm listening to this book because I've heard some podcasts with the author. There's a lot of people talking about this book. I wanted to check it out because he doesn't believe things that I believe. In fact, he takes a third-party perspective look at some of the things I believe, and so that helps me get outside myself and grow a little bit. So I really enjoy it. If you're not listening to audiobooks, you really should be. You're smart people. This part is a big deal for me, and I know this part can be a big deal for you because audiobooks literally have changed my life. So audible.com/smarter, that's how you can support Smarter every day, or text the word smarter to 500-500. Thank you for considering that. Last thing, I want to say thanks to the guys at Infinitec. A treadmill made of treadmills. That is insane. You're there, man. This is just a control systems problem at this point, isn't it?
We just need some controls engineers.
You need some controls engineers.
Yes.
Hire a couple.
That's what this is at this point.
Yes.
At this point, it's just computer stuff and math, so this is doable. I hope you enjoyed this video enough to subscribe. If you do, there's a little bell beside the subscription button. If you haven't enjoyed it enough to hit the bell to get a notification on your phone every time I upload, then don't. That's completely okay. Anyway, I'm Destin. You're getting smarter every day. Have a good one. Thanks for learning with me. Cat. You're gonna fall. You fell. You jumped. Whatever. What are you doing? Why are you making noise?